This is our acoustic sound wall for Kendall Whittier, and its purpose was Jennifer at Kendall Whittier requested this sound wall in order to make a fun and stimulating activity for the children in her class. This project was created by Nick Tate, myself, Austin Hubbard, and Sophia Ulsner.
Okay, so our plan was to mount this board onto a wall, and we thought that the best way to do this would be to have smaller boards that could be lighter weight and more flexibly arranged. So this particular board has 4 instruments, and we wanted to have different boards, have different themes, and as you can see, this one is kind of a metallic theme. In the future, we're going to have more boards come out, probably over multiple semesters with different themes. This semester, we plan on taking this project to Jennifer at Kendall Whittier to see how she likes it and kind of just to show her our progress on it. This is what we consider a working prototype that future teams can learn from. And we also think that this is the type of project that can be continued for multiple semesters, even with new clients, just because it's such a universal type of project.
The total money spent on this project was around $180. This includes multiple sheets of material, 4 instruments, 2 sets of mallets, and nuts and bolts. The cost of the instruments came out to about $20 each. The most expensive part of this project was the ABS sheets, the front and back, and the foam core, which came out to be $70 worth of raw material.
The board is comprised of 4 different instruments and 2 slots for 2 mallets each. The first instrument that was installed is the wind chimes. Next is the bells. Next we have a gong. And lastly, a kalimba. The board is made out of 2 sheets of ABS, 1 sheet in the front and 1 sheet in the back. The middle section is a polyethylene polyurethane mixture that acts as a foam. The purpose of this foam is so that the instruments can be offset from the front so that they can have room to swing back and forth. Here is the original SolidWorks design of our project. This is where we came up with the idea to offset the instruments into the board. Next, we picked our materials and came up with this board, which is the one we're using now. We found out that unfortunately the laser cutter could not accept the dimensions of our project. This is a 2 foot by 2 foot, and the laser cutter can only accept about 1.5 by 2.5 feet. So to fix this problem, we cut the board up into 2 sections, a top section and a bottom section. And then we were going to use these screw holes right here to secure the bottom and the top sections. Unfortunately, once again, we learned that ABS can't be used in the laser cutter, so we had to go to handmade dimensions on the ABS and cutting the board by hand. Some things that we learned that might be helpful for future teams is, instead of ABS for the front and back boards, you may want to consider using acrylic instead, as it can be cut in the laser cutter and ABS cannot. So making these holes for the instruments would be much easier. Another thing to keep in mind is that the laser cutter is only 32 inches by 20 inches. The board is 24 inches by 24 inches. Therefore, you would have to cut the board in half to fit it into the laser cutter. So maybe think of other ways of manufacturing the front plastic. The last thing is to consider using different options for the foam core as opposed to polyethylene polyurethane. This foam was a bit difficult to work with as it was really sticky.